Put an 18-volt tool battery beside one labeled 20-volt max, and the second one sounds more powerful. 2 extra volts should mean more speed, more torque, and more work per charge, right? Not necessarily. In one of the most common cordless tool examples, those two labels can describe the same nominal voltage class. The difference comes from which moment in the battery's voltage curve the label chooses to emphasize. That sounds like a marketing trick, but the engineering behind it is useful. Once you understand nominal voltage, no-load voltage, and voltage under load, battery labels become much easier to read, and you stop paying for a larger number when the real differences may be somewhere else entirely. The first idea to forget is that a rechargeable battery has one perfectly fixed voltage. It does not. Its terminal voltage changes with state of charge, temperature, cell chemistry, current, and age. Fresh from the charger, the open circuit voltage is near the top of its allowed range. During use, it falls. When a motor demands a large current, internal resistance causes an additional temporary drop called voltage sag. Release the trigger, and part of that voltage returns. So a single number printed on the case must be a rating convention. It can be a nominal value intended to describe the useful operating region, or a maximum value measured under defined conditions. Both can be legitimate, but they answer different questions. Now look inside a typical battery in this class. Electrically, its basic stack contains 5 lithium-ion cell groups connected in series. A larger capacity pack may place 2 or more cells in parallel inside each group, but the number of groups in series still sets the voltage class. Series connection adds voltage. Parallel connection mainly adds current capability and capacity. This distinction explains why a compact 2 amp-hour pack and a larger 5 amp-hour pack can both belong to the same 18-volt platform. Their cell count and arrangement are different, but both present 5 series groups to the tool. Capacity, current delivery, cooling, and internal resistance can change dramatically even when the headline voltage stays the same. For a concrete cell example, Murata's US 18650 VTC5 datasheet specifies a nominal voltage of 3.6 volts. Multiply that nominal value by 5 series groups and you get 18 volts. Nominal does not mean the battery is locked at exactly 18.0 volts. It is a reference rating that makes packs and systems easier to classify and compare. This is why manufacturers such as Makita and Bosch describe major professional cordless platforms as 18-volt systems. It is also why energy calculations usually combine nominal voltage with amp hours to estimate watt hours. The nominal label is less dramatic than a maximum number, but it is often the more useful shorthand for the battery's working class. DeWalt explains its own label in the footnote on the official 20-volt max platform page. The company says the maximum initial battery voltage, measured without a workload, is 20 volts, while nominal voltage is 18. Its support documentation also presents 18 volts and 20 volts max as equivalent naming conventions. That is the core answer. One label highlights nominal voltage, the other highlights an initial maximum no-load rating. There is an important technical caution here. A cell datasheet may specify a different absolute charging limit. For example, the Murata cell cited for this video uses a 4.2-volt constant voltage charge condition, and Panasonic describes maximum pack charge voltage as 4.2 volts multiplied by the number of series cells. A rounded platform name is not a precision voltmeter reading. The max number becomes even less descriptive as soon as the tool starts working. A drill motor or circular saw can demand a large burst of current. Every cell, nickel strip, connector, protection transistor, and contact has some resistance. Current flowing through that resistance produces a voltage drop. A warm, healthy, high-power pack may hold its voltage better than a worn or cold pack. A compact pack may sag more than a larger pack built with more parallel cells. This is why 2 batteries with the same printed voltage can make the same tool feel different. The stronger pack is not secretly a higher voltage platform. It may simply have lower internal resistance, better cells, more parallel current paths, and better thermal design. So why would a manufacturer choose the larger figure? Product positioning is an obvious reason. 20 looks stronger than 18 on a shelf. But maximum voltage naming is also used consistently across several cordless families. 12-volt max commonly corresponds to a 10.8-volt nominal 3-series system, and 60-volt max corresponds to a 54-volt nominal 15-series arrangement. DeWalt's own support material publishes those equivalences. The important word is max, and the important detail is the footnote defining the measurement. This is not proof that every 18-volt and 20-volt product from every brand is interchangeable. It only explains how two different naming conventions can describe the same underlying voltage class. If the printed number is not enough, what should you compare? Start with the cell type and the pack's series parallel layout. More parallel cells can reduce the current burden on each cell and increase usable capacity. Look at amp hours, but remember that capacity alone does not guarantee high power. Internal resistance, allowed discharge current, contact quality, cooling, and temperature limits all matter. Then look at the tool. A well-designed brushless motor and controller can turn available battery energy into useful mechanical work more efficiently. Manufacturers may also tune premium tools to communicate with premium packs and permit higher current. In practice, a modern 18-volt pack and tool can outperform an older product wearing a larger-looking voltage badge. Between the cells and the tool sits another major part of the story: monitoring and protection electronics. Texas Instruments documents battery monitor devices for 3 to 5 series lithium packs that can measure cell voltages and support balancing, overvoltage, undervoltage, overcurrent, and temperature protection. The exact division of responsibility differs between brands. Some protection may live in the pack, some in the tool, and some in the charger. That is why a battery is more than a plastic box containing cells. Its electronics decide when charging must stop, when discharge is unsafe, and when temperature or current has crossed a limit. Bypassing those systems with an improvised adapter can create risks that are completely invisible from the voltage printed on the case. This leads to the most practical warning in the video. Never use the 18 versus 20 explanation as permission to connect arbitrary packs and tools. DeWalt sells a dedicated adapter for using certain 20-volt max batteries with many older 18-volt tools, and the product page lists exclusions. The need for that adapter proves the point. A similar voltage class does not make the mechanical interface, terminals, charger, battery management, or current limits automatically compatible. Makita likewise groups compatibility by CXT, LXT, and XGT platforms. Bosch tells users to choose batteries from the compatible voltage system. Follow the manufacturer's compatibility list, especially for chargers. A connector that can be forced to fit is not an engineering specification. When comparing cordless tools, use a 4-step check. First, identify whether the advertised voltage is nominal or maximum and read the asterisk. Second, compare the battery platform, not just the number. Check official compatibility for the tool, pack, and charger. Third, compare energy and runtime information such as watt hours or amp hours within the same voltage class. Fourth, look for evidence about power delivery, cell type, pack size, cooling, permitted current, and independent performance tests under the same workload. Do not assume 20 beats 18 or 40 beats 36 until you know how each figure is defined. A useful specification states its conditions. A bare number without conditions is mostly a signpost to the footnote. Here's the answer in one sentence. An 18-volt nominal lithium-ion tool battery class can be marketed as 20 volts max when the label uses a maximum initial no-load convention instead of the nominal working class convention. It does not automatically contain more voltage, more energy, or more performance than an 18-volt competitor. The real engineering lives in the cells, series parallel layout, resistance, thermal design, protection electronics, motor, and controller. Read the footnote, stay inside the approved battery platform, and compare performance under the same conditions. That turns an impressive number back into what it should be, one specification among many, rather than the entire story.